This is tutoring for intermediate algebra at Radford Valley Community College. In this video, we're going to go through examples of chapter 11.6, equations in quadratic form. So remember, the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. Well, if you notice in this equation, the form is very similar, but not quite the same. However, if we look here, we have an x squared term and x to the fourth term. There's a relationship there. So I can say, okay, let u equal x squared. Okay, well, I want to get another term that has a u in it, but the thing is I got to substitute for x to the fourth. Well, if I square both sides of this, I'm going to get u raised to the second, which is u squared, and x squared raised to the second is x to the fourth. So now I can substitute. So x to the fourth is u squared, so it'll be u squared plus 2x squared, well, x squared is u, minus 3 equals 0. So now I got to find two numbers that multiply to negative 3 and add up to 2. Well, 3 and negative 1, because 3 times negative 1 is negative 3, 3 minus 1 is 2. So now I can rewrite it as so, u squared plus 3u minus u minus 3 equals 0. I have my one group here, my other group here. Well, this group, I can factor out a u plus 3. Now for the second group, the leading coefficient is negative. Whenever you see that, you always want to factor out a negative. So factor out the negative 1 here, and you're going to have u plus 3 equals 0. So now we're left with u minus 1 times u plus 3 equals 0, which means I'm going to move this over to here. So that would mean, okay, well, this guy, u minus 1 is equal to 0, and also u plus 3 is equal to 0. So that means u is equal to 1 here, and u is equal to negative 3. But remember, I'm trying to solve for x, so now I want to substitute what my u value is. U is x squared. So x squared equals 1, x squared equals negative 3. I take the square root of both sides here. I get x equals plus or minus 1. I take the square root of both sides here. X equals plus or minus I square root of 3. So the solution here would be x is negative 1 and 1, I square root of 3, and negative I square root of 3. That's the first one. So I'm going to put this line here to separate my work from the next one. Now this one's the same general idea, except I'm not going to use u again because I used it here. I don't want to make it more confusing, so I'll call it w. So let w equal x squared. And if I square both sides, I get w squared equal to x to the fourth. So 3x to the fourth is 3w squared equals 10. X squared is w plus 8. If I subtract 10w and 8 from both sides, I get 3w squared minus 10w minus 8 equals 0. And now I can apply the AC method. Two numbers that multiply to, well, 3 times negative 8 is negative 24. So two numbers that multiply to negative 24 and add up to negative 10. Well, negative 12 and 2, because negative 12 times 2 is negative 24. Negative 12 plus 2 is negative 10. So I can rewrite it as so, 3w squared minus 12w plus 2w minus 8 equals 0. Do factoring by grouping. So here I can factor out 3w, and I'm going to have w minus 4 left. Here I can factor out a 2. Now make it w minus 4. So then now I'm going to rewrite it over here. 3w plus 2 times w minus 4 equals 0. So that would mean that 3w plus 2 equals 0, and w minus 4 equals 0. So here, w is going to equal negative 2 over 3, or negative 2/3. And here, w is going to equal 4. So then that means, well, again, what is w? X squared. So negative 2/3, x squared equals negative 2/3, and x squared equals 4. So therefore, I'm going to rewrite this over here, and I'm going to have space here. I apologize for that. So x squared equals negative 2/3, and x squared equals 4. Take the square root of both sides, and x equals plus or minus I radical 6 over 3. And here, take the square root of both sides. X is going to equal plus or minus 2. So the answer becomes x equals negative 2 and 2. And the other one is going to be negative I square root of 6 over 3 and I radical 6 over 3. On to the next slide. So here we're going to do solving more equations in quadratic form. Well, here I can say, okay, I'll call it v. Let v equal, you can call it anything you want as long as it's not the same variable that, in the equation that you're trying to solve for. So let v equal x to the third. If I square both sides of this, I get v squared equals x to the 2/3 power. So 3x to the 2/3 becomes 3v squared plus 18x to the third is v equals 48. Subtract 48 from both sides. That gives me 3v squared plus 18v minus 48 equals 0. I can factor out a 3 here, and it becomes v squared plus 6v minus 16 equals 0. I can divide both sides by 3. I'm going to draw an arrow to move this up here. So that leaves me with v squared plus 6v minus 16 equals 0. And then now, the AC method, two numbers that multiply negative 16 and add up to 6. Well, 8 and negative 2, because 8 times negative 2 is negative 16, 8 minus 2 is 6. So that would be v squared plus 8v minus 2v minus 16 equals 0. So out of this group, I have two groups here. Out of this group, I can factor out a v and make it v plus 8. This group, again, I have a leading negative coefficient. I factor out a negative 2. And if I factor out negative 2, I get v plus 8 equals 0. So now that gives me v minus 2 times v plus 8 equals 0. I set these both equal to 0 here. V is going to equal 2 here, and v is going to equal negative 8. But again, I'm trying to solve for x. So what does v equal? V is x to the third. So x to the third equals 2, and x to the third equals negative 8. So if I cube both sides of this, that gives me x equals 2 to the third, which is 8. And then cube this side and this side, it's x equals negative 8 to the third power, which is going to be negative 512. So therefore, x equals 8 and negative 512. this for this guy. And the last example we're going to go through is this. Now, this doesn't actually involve any kind of substitution, but if I have an equation like this, there's actually two ways you can really go about it. However, I recommend factoring so you don't lose some solutions. Now remember, this is a fourth degree polynomial equation, so that means we can have up to a maximum of 4 solutions. So first off, for here, I want to get rid of that 1/3. Okay, well, let's multiply the whole equation by 3. So 3 times 1/3 x to the 4th is x to the 4th. 3 times negative 27 is negative 81. And 3 times 0 is 0, so equals 0. Now, yeah, okay, a lot of people would say, yeah, add 81 to both sides and then take the 4th root of both sides. But the problem is, if you do that, as I mentioned before, you're going to lose solutions. You only get one solution here. So that's why you want to solve it by factoring. So this is difference of squares. Okay, so if we think about it, yeah, you could do a U substitution or something like that, or I don't know, in this case I'll call it R. So if you wanted to get, like x, this looks similar to the difference of squares where, a squared minus b squared, and it's a minus b, a plus b. So if you look at it this way, basically you could rewrite it like so. So x to the 4th, well, x to what power squared gives you x to the 4th. In other words, x to what power times itself gives you x to the 4th. Well, that's just x squared. Like that. Okay, and then minus 81 equals 0. Well, now I can just say, I do a substitution here. I'll call it r. Let r equal x squared. So then, since r equals x squared, that's going to be r to the 2nd minus 81 equals 0. I could factor this by difference of squares. It's going to be r minus 9, r plus 9 equals 0. So then now r minus 9 equals 0, r plus 9 equals 0. So r is going to equal 9, and r is going to equal negative 9. But remember, all right, we're not trying to solve for r, we're trying to solve for x. So I'm going to move this back over here. What is r? X squared. So x squared is going to equal 9, and x squared is going to equal negative 9. Take the square root of both sides of the equation here. You get x equals plus or minus 3. Take the square root of both sides of the equation here. X equals plus or minus 3i. So therefore, the solution to this is x is equal to negative 3, 3, negative 3i, and 3i, and that is the solution to this guy. I hope this video helps, and we'll see you all next time. Bye-bye.